Hello, my name is Rohit Pandre, and in this video I am going to talk about sortings in DSA, that is data structure and algorithm. So what is sorting? Suppose you have an array of n elements. What's n? N is the length of array. Okay. Then what to do with that array? Suppose you have to perform some operations, and if your array is sorted, then these operations will require less time to execute and less space also to perform that particular function or task. Suppose you have an array of these elements, that is this 40, 21, 8, 17, 20, that's 12 or 34. It's 51, means I'm seeing a reflection of it. Okay. Suppose you have this array, then you will simply use a sort function in Python if you are using Python, and this array will get sorted. But there are 6 manual methods in general of sorting arrays. The first is bubble. What do you do? Suppose you have a big array, then you just compare the nearby two elements, and if the both elements are unequal, we will just keep the lesser element. We will look for the lesser element and the bigger element, and if we found that at the ith place, means at the initial place, the element is big, then the next place we will simply swap them. That's a simple bubble sort. Okay, what's next? The next is selection sort. What we do, we simply select the element from the whole array which we found as less. Then what we do, it's very simple. We do manual selection and find the minimum element from the array. For example, if our pointer is here, and we scan the whole array and we found, okay, this 8 is small, then we will simply select it and keep it in front to make the array more sorted, and we repeat this process again and again, so our array will be sorted. Okay, so what's the next sorting algorithm? It's insertion sort. As its name says, we insert something. What we insert? We insert some elements from the array. Means we create two parts in the array. The one part is sorted and the other part is unsorted. Then we will move the elements from unsorted part to the sorted part. For example, we will move 8 from here to here, or we can move the 17 at the first place and 8 at the 0th place. Okay, that was a rough idea about the insertion sort. See, now the next is merge sort. Now the next two are divide and conquer strategy algorithms. The first is merge sort, the next is quick sort. The merge sort is divide and conquer. Here we divide the array in smaller chunks, and we just broke them into small pieces of individual elements, and while merging them, we just compare the value of the two elements in array. For example, we have this separate element as 34, or we have the separate element as 8. Now at merging stage, we will compare and keep the 8 in the left hand side and the 34 at the right hand side, and thus we can simply do merging from the divided selected elements. That's a simple way of merge sort. Okay, what's next? The next one is quite interesting. Quick sort. The quick sort, we keep a pivot. You might ask, what is pivot? Pivot is like a pointer. For example, our array starts from here, then it is the ith position, and our pivot is 34, and we keep the j at 51. Then we do some operations and we just check that if the ith element is lesser than the, means the ith element tend to found for the lesser element. Sorry, my mistake. I was saying here is I, here is the pivot, and here is j. The ith element will look those elements which are bigger than this pivot, which are larger than the pivot, and the jth element will look for the element who are less than the pivot. And after some conditions, this a and j position will get swapped, and when the I and j cross each other, we will keep our next pivot. And by doing this, suppose we only remain 3 elements in our sub array, then maybe this may be a new pivot, or this may be a new pivot point. And by using this pivot and the divide and conquer strategy, we simply sort those arrays. Okay, then what is the last sorting algorithm? That is heap. What is heap? Heap is heap is the data structure which uses a tree. It has a max heap and min heap. The max heap has the maximum element at the top, and the value of the elements is gradually decreased as we move towards the leaf. And the next is min heap, where the topmost root element is minimum and the elements at the leaf node are maximum. So what we do in the heap sort is we have a array and we form a tree with help of this array, and we form a tree of maximum heap. Means the element 51, which is the maximum, will be at the root at the top of the maximum heap tree, and the element 8, which is the minimum, will be at the end, at the most leaf node of this heap tree, the heap data structure. And after few time, we will just swap them. We will swap the less value position with the next with the greatest value position. And when we do this, our heap data structure is disturbed. Then we again do heapify. What's meant by heapify? Heapify is simply that converting those elements again into the heap structure. But when these structures are again converted into the heap structure, then we will take the second largest element at the top, at the root, and we form the maximum heap tree again, and we do sorting. Okay, these was the sorting algorithms. But at the end, I would like to tell more about the time complexities. You may have heard about time complexities of order of n, order of n square, or order of n log n. Now I am going to tell you the time complexity of these algorithms. The first one was bubble sort. Bubble sort, if the all elements are sorted, then it will take big O of n time complexity, and the average case is order of n square, and the worst case is also order of n square. Then talking about selection sort, the best, average, and worst case is order of n square. Then talking about insertion sort, when the elements in the array are sorted, the best time complexity is big O of n. And in the next two cases of average and worst case, it's order of n square. While talking about the divide and conquer strategies, their time complexity differs. For the merge sort, the best case time complexity is n log n, and for the average case, it's also n log n, and for the worst case also, it's n log n. Means this merge sort is kind of better than other sorting algorithms, but generally this merge sort is preferred in the linked list data structure than array. Then we talk about the fifth sorting algorithm, that is quick sort, which has the best case time complexity of n log n. Then the average case time complexity as also n log n. But here, despite of its having a divide and conquer strategy, it has the time complexity of n square. Now let's talk about the last sorting algorithm, that is heap sort. Heap sort has the all three time complexities of n log n. So that was my video, and I just told you briefly about the sorting algorithms, and if I get wrong at some point, sorry for that. Hope you like that video, and I am going to provide the Python codes for these 6 sorting algorithms in the description. And thank you for watching video.